Dear students, today we see about the determination of cam jump speed phenomena. This is the experimental setup for the cam jump phenomena. So this is the cam by attached to the DC motor, and then this is the DC power supply. This is used for the variation of the speed rotation for the cam jump. So this is the spring setup, helical spring we are used, and then spring loaded setup. So this experimental setup we are going to find the cam jump phenomena. So aim of the experiment to determine the cam jump phenomena. Next, this is the experimental setup, and then tabulation, the actual cam speed, and is in this spring rotation, and then deflection and theoretical value of speed. So next we are going for the formula used. Cam jump speed is equal to formula used, deflection is equal to compression of spring plus lift, and then del is equal to C plus 2 into E. So we have the standard value, gravity is equal to 9.81, E is equal to 0.06 meter, and K is equal to 0.55 Newton per mm, and mass is equal to 0.292 kilogram, and then stiffness of the spring, K is equal to root of G D power 4 divided by 8 into D cube N. So this formula we are going to find the spring stiffness, and then coil diameter D is equal to 1.5 mm, and capital D is equal to 26 mm. Number of coil is equal to 18. So this spring used for the to find the determination of cam jump phenomena. Next we are going to do the experiment. So first switch on the power supply and increase the RPM gradually. So when the motor is rotated and the cam is jumped, at the speed we are going to mention the starting of the cam jump phenomena. So this is the speed for starting speed for the cam jump phenomena, and gradually increased. So next we are going to give the spring compression. So here we are going to rotate one revolution. So now the cam jump phenomena is reduced, and then we are going to take the reading, and next we are going to increase the speed of the cam, and again we are going to give the compression for the spring for one revolution and reduce the cam jump phenomena. Next we are going to increase the speed, and again we are going to give the one revolution for the speed, and then increase the speed. Next we are going to give the one revolution for the compression of the speed. Again we are going to increase the speed. So this is the procedure to determine the cam jump speed phenomena. So here the increase the speed of the cam, and then to reduce the cam jump for the given spring rotation, and this procedure to follow up to 5 trials, and finally we done the model calculation, and finally so this is the model calculation. So actual cam jump speed is, first one is 505 RPM. So speed compression is spring compression is 0. At the time the deflection is 12 mm and theoretical value is 747.45 rpm. So this is the procedure, and next we going to the increase the speed of the motor 611 rpm, and give this compression spring is one rotation, one revolution. At the time we got the deflection 13 mm, and find that theoretical speed is 768, as well as we follow the four step for the final speed of the cam jump phenomena. So next we go for the model calculation. Speed, already we discussed about the formula. So deflections is equal to compression of the spring into compression of the spring plus 2 into E. So we have all the values and calculate the deflection and speed of the cam jump. So speed is finally we got the n is equal to 747.45 rpm. So this is the one model calculation, as well as we follow the 4-1, and the result, thus the speed is determined by the cam jump speed for the variation of the cam rotation.